To actually be able to use textures or images for our bird nodes, we will naturally have to add them to our project first. And we will do so in the asset catalog, just like we did for our blocks. Again, we do provide graphics for all the different types of birds, which you can use and just get from the resource folder. I do have 4 folders here for all of the different birds called red, blue, yellow, and gray. And I will just select these 4 folders and drag them into my asset catalog, just as they are. As soon as I did, I can just right click on these 4 folders and select new folder from selection, which I will call birds. We now have this birds folder containing all the different colored bird graphics. For now, we will test this with our red bird, and we are going to use this red1 graphic to do so. I will begin back in my bird class, where we as of now just initialized our bird node with a certain color that we then passed onto the superclass initializer. Now we want to define an actual texture instead of a color. So let's start by replacing this constant color with a constant texture that now has the type skTexture. In the superclass initializer, I will then not set the color, which will be UIColor.clear from now on. Now I have to specify the right texture for all my different possible birds. We already have a switch statement here, so let's try this. For the case red, I'll just say texture is skTexture with an image named. Just like for the texture of our blocks, I can pass type.rawValue as the string for the image name. Since we do have our raw value of type string from our bird type enumeration being red, blue, yellow, and gray. For the birds though, I will have to append 1 as a string, since the bird images are numbered 1 through 4, which we will need for the animation later on. Now if you see this line for the case red, maybe some of you will notice a little something. We did set the texture name to be type.rawValue appended with 1. What would we have to set the texture name to for the case blue? Exactly the same, right? Because we can now just always use the raw value of the type property to get the right texture. And this means we actually do not need this switch statement at all, which then again means that we do not need this texture constant to be a force unwrapped optional. Instead, we can just directly set it to this value. So let's delete the entire switch. And finally, I will just, in the superclass initializer, pass the texture for the texture parameter. For the size, since my images are not square, I will begin by just passing texture.size so that we have the correct aspect ratio of our image. This might not be quite right though, since our bird will be pretty large like this. But for now, it should be okay like this. And this does conclude the initializer for our bird class. And we will once again go into the game scene class and see where we added the bird and if we need to change anything. This of course happens in the add bird method, where we begin by checking if we still have a bird and then set it for our bird property. We add the physics body, position the bird, and then add it to our scene. This means that we do not really need to change anything that we've set specifically for the colored square here. We just add the bird and its physics body, which is fine. So let's run the app. And we can do that on the simulator real quick to just see how the birds are looking. Alright, the app started. And just like I thought, our bird is now displayed with the right texture. However, it is quite a large bird and not really how we want it to look in the game. Since I also don't want to bring our bird to a static size such as 40 by 40, which will distort the image's aspect ratio, it would be nice to maybe have a convenient method that we could use throughout the app and also other SpriteKit applications we might develop. This method ideally could scale our nodes to a certain size while maintaining its original aspect ratio. So I'll just stop the app, and we will now do exactly that by creating a helper method, which we can use on all SK nodes and their subclasses. I'll begin by, in our project, creating a new group, which will get the name extensions. And inside of this group, I will create a new file. It will be a Swift file, and I will call it sknode plus extensions. This name has become somewhat popular for files that contain just extensions for a certain type, so that anybody seeing our project can easily tell that this file contains extensions for the sknode class. I'll begin my new Swift file by importing SpriteKit instead of Foundation. And then I will create an extension for the class sknode. Our extension will, as of now, only get one new method. It will be an instance method, so that we can call it, for example, with our bird node, which is a subclass of SKSpriteNode, and therefore also sknode. I will call the new method aspectScale with a parameter toSize of type CGSize, a parameter width of type bool, and finally a parameter multiplier of type CGFloat. I want to be able to call this method with any node to scale it to a certain size. The width parameter will define whether I want to scale the node to the height or the width of the passed size. The other dimension will then be calculated to maintain the node's aspect ratio. The multiplier can be used to scale nodes to maybe twice or half the size or something like that. So what do we need to achieve this? I will begin by defining a constant called scale. This constant's value will be set depending on whether the parameter width is true or false. Therefore, I will use a ternary operator that checks the value of width. If it is true, I will set scale to size.width times multiplier divided by self.frame.size.width. This self.frame.size.width will just give me the width of the node itself. So to get the scale we need to divide our goal width by this value. If width is false, we will then obviously set scale to size.height times multiplier divided by frame.size.height. With this, I will always get the right scale for either scaling to a width or a height. I can then use the CGFloat value in scale to set the scale for our node that called this aspectScale method. Therefore, I will just call self.setScale and pass scale. To see if all this works, we need to test it with our bird node. And to do so, I will go back to the game scene. Inside of the addBird method, I will now, after adding the bird to the scene, call bird.aspectScale, where I will have to pass a size, whether we want to scale to width or height, and a multiplier. For the size, I want to pass the size of one tile of our map, which I can do by passing mapNode.tileSize. Let's scale this to the height of our tiles. So let's set false for width, and the multiplier will be 1.0, so that it will not change anything. Let's run it again, and if it worked, our bird should now be much smaller and have about the size of one of our tiles. The app started, and our bird looks much better. This size makes a lot more sense for our Angry Birds game, and we could now launch the bird at our blocks. I won't do that now, since you could already see that running this in the simulator is pretty painful because of really low frame rates. You could, however, run this on an actual device, if you like, and see for yourself if you are comfortable with the size of the bird. And if not, you can adjust it obviously. We do now have our bird and the block graphics, which makes our game already look pretty decent. We do, however, only have this one static scene, which obviously can't be our end goal for the game. We do want to have multiple levels and such. We will need a level selection screen, and with that, the possibility to load different levels in our game. While in the best case being able to handle all the different levels with our game scene class, which we have here, containing all the functionality we have developed together and only visually create another setup each time. So let's take a look at what we need to achieve this.